Bar Harbor, Maine is a fishing town. Well, a lobster town more than anything. It's picture perfect. It's quintessential. It's charming. Okay, it's a bit of a tourist trap too, but still, it's perfect. And the best part is, mid-afternoon, usually like 2:30 or 3, the lobster boats come back and they ring a bell. Chefs from all the restaurants head down to the docks to buy fresh lobster. And you can go too if you want a fresh one for your pot at home, or you can just watch the hubbub and then go make a reservation at any one of the dozen places along Main Street. And yes, it really is called Main Street because Bar Harbor is just that kind of town. In those restaurants, they will serve you cold water Atlantic lobster, grilled or boiled, whichever you prefer, but always glistening with a thin layer of garlic butter. That's about it. That's all you need to know about Bar Harbor. Tourists and lobsters, lobsters and tourists. Well, and there's one other thing. It's the 10th of May, 1989, inside a one-story brick-faced building. At 1:15 in the afternoon, a fire breaks out. It starts in a part of the building that's in the middle of renovations. Now, there are more than 200 people at their desks, so it doesn't take long for someone to notice the smoke and pull the fire alarm. But there are construction materials, sealants, paints, that kind of stuff, stored in multiple rooms near the fire because of all the renovations. So the fire gets really hot, really quickly, and it spreads. Employees scatter. They grab their purses, their jackets, maybe a family photo from the desk, but there's no time to remove the building's most precious contents. The fire department arrives quickly. I mean, Bar Harbor isn't that big, so they're not far away, but the heat is too intense already for them to get inside. So, they focus their efforts on protecting the nearby buildings and making sure that the fire doesn't spread to those. It takes almost 2 hours to put the fire out entirely. And they do manage to keep it from spreading, but that one building, the one where it started, it's completely gutted. What made this such a tragedy was the incredible loss of life. Not human, well, not immediately at least. All the people working there got out in time. One of the construction workers went to hospital to get checked out, but he was fine. The people were okay. But the death toll that day was over 500,000. That's 500,000 small white mice. You see, the building that was destroyed that day was a breeding facility for research mice. This one facility sent mice, genetically engineered to be perfect, repeatable test subjects, to labs all over the world. These mice were used by researchers looking for cures to cancer, AIDS, diabetes, and thousands of other conditions. So, while no human lost their life in the fire that day, all around the world, life-saving research was delayed or put on hold or canceled entirely, all for a lack of mice. And when life-saving research is halted, well, fewer lives are saved. So, in that way, the fire did cause a loss of human life, too. I'm Dan Riskin, and this is Inside the Breakthrough, How Science Comes to Life, an original podcast by SciMar. In today's show, I'm going to talk about using animals as test subjects. And I'm also going to explain the origins of the term guinea pig when it refers to people who volunteer for clinical trials. I mean, I guess I have to explain that because that is the title of today's show. Episode 9, Guinea Pigs. As we always do, I'm going to share a couple of stories from history, and then I'm going to connect those to the research SciMar, that's the company that produces this show, is doing right now in their fight against type 2 diabetes. And while they're currently doing clinical trials on human volunteers, their early work did include studying diabetes in animals. We'll tell that part of their story in just a bit. But first, this.
This is a picture of a major American personnel problem.
Let's start, as we often do, with a clip from an old film.
An ugly sore that doctors call a peptic ulcer. eating away at the wall of a man's stomach.
It's a medical film produced by the Oklahoma State Department of Health in 1959.
Every year, ulcers bring pain and unhappiness and expense to thousands upon thousands of working men and women.
Here's a funny thing about this film. It's about stomach ulcers, but it's produced by the psychology department. They have a pretty interesting way of looking at ulcers. So the film setup, it's the story of Steve. He's a rising executive and married father of two. He works really hard, but sometimes he loses his temper on his coworkers.
Mr. Hall, are you all right?
What's the matter with you? Who asked you to come chasing out here?
Why is he such a grump? Well, in part, it's because he has severe stomach pain. So he goes to see his doctor, who tells him he has an ulcer.
But why? Why should I have an ulcer? What could have brought it on?
There's nothing too mysterious about it, really.
According to the doctor in the film, his ulcer is the result of his stressful lifestyle. That's what the dominant thinking was for a long time, that stress gave you ulcers.
What I want you to do is to work on your attitude.
My attitude?
That's right. Ulcers breed on the wrong kind of feeling.
At the end of the film, Steve leads a more balanced life. He spends more time with his family, and he stops yelling at his coworkers.
Well, that's the end of our story, a happy ending too. You see, that's what it takes to win the fight against an ulcer at work.
That was 1959. That was the best information we had, but it was wrong. I mean, it's still a good idea to live a balanced life and spend time with your family and not be a jerk in the office, Steve. But none of that has anything to do with ulcers. You see, ulcers aren't caused by stress. They aren't caused by spicy foods or too much bourbon or any of the commonly held beliefs. In 2005, the Nobel Prize for Medicine was given to the people who figured out what was really causing ulcers. It was a bacterium known as Helicobacter pylori. Now, you're probably thinking I'm going to tell you how they did a bunch of experiments on lab animals to figure that out, because that's what today's episode is all about. And yes, kinda that's where this story's going, but there's a bit of a twist. We start at Harvard Medical School in 1940. Dr. Abraham Stone Friedberg was doing research on cardiovascular conditions, but he stumbles across reports by other researchers about finding bacteria in the stomachs of ulcer patients. Dr. Friedberg was a keener, and even though it wasn't his specialty, he got permission to use the pathology lab in the evenings after 5 p.m. and on weekends. So he's working with some samples of stomach tissue that a surgeon friend snuck in for him. So the standard treatment at the time for ulcers was to have surgery and remove the part of the stomach where the ulcers are and then stitch the rest of it up again. Well, that surgeon buddy would sometimes sneak that piece of stomach he removed over to Friedberg's after-hours lab. In those samples, Friedberg isolated and identified a new kind of bacteria. But when he tried to publish his discovery, he was mocked and he was ignored. Everyone knew that bacteria couldn't survive in the acidic environment of the human stomach, so clearly he had made a mistake, or he maybe had some contaminated samples. His superiors, and he was only 30 at the time, told him to quit wasting his time. So he returned to his specialty, which was cardiac physiology, with an emphasis on thyroid disease. And it's worth mentioning that a decade or so later, he did publish a revolutionary approach for treating thyroid cancer with radioactive iodine. It was groundbreaking, and it saved many, many lives, so maybe in a way it was for the better that he bailed on the ulcer project. But because he bailed, the world just kept on believing that ulcers were caused by stress.
Every little upset pumps more hydrochloric acid into the stomach to eat holes in the lining.
Fast forward to 1961 in Greece. A doctor named John Lykoudis started pushing the idea that ulcers could be treated with antibiotics. He claimed to produce results far better than what established treatments were providing. He just couldn't explain why those treatments worked, though. See, he was a doctor, not a scientist, so he hadn't done controlled studies, he just treated his own patients. And because those patients experienced those positive results, he developed a large and loyal following of people who believed in his methods. Well, All this did not go over well with the Greek medical establishment. They still wanted to treat ulcers the old-fashioned way by cutting people open and removing a piece of the stomach wall because they had evidence that that was working. There weren't any clear data on the antibiotics, there was just this pile of testimonials. They accused Lykoudis of selling snake oil. And it's not surprising when you look at his behavior. I mean, he's claiming these incredible results and he has no explanation for why it's working. So it's kind of no surprise that he was indistinguishable from the crowd of pseudo-scientific quacks that existed then, just as they do today. Dr. Lykoudis gets called before a tribunal, and the Greek medical board fines him 4,000 drachmas. That's roughly equivalent to just over $1,000 US in today's currency. So yeah, the fine probably didn't sink him financially, but the stigma of being found guilty of promoting false claims, that pretty much ended his medical career. Friedberg in the 40s and Lykoudis in the 60s, they were both onto something scientifically, but they both faced a problem we keep returning to in this series. They were up against an established paradigm. Every medical textbook in the world explained very clearly that ulcers were caused by stress, which leads to an excess of acid being released into the stomach. Those textbooks didn't explain that as a theory. It was stated as a fact. The Oklahoma Department of Health even made that movie about it.
Now look, Steve, I'm your doctor. Remember? Your friend. You've got to face up to reality. You've got to be honest with yourself about the way you feel about things.
Then along came Barry Marshall. Dr. Marshall was a gastroenterologist in Western Australia in the 1980s, right around the time that Crocodile Dundee came out in movie theaters.
That's not a knife. That's a knife.
He started doing research on two questions. Are there bacteria that can survive in the human stomach? And do those bacteria cause ulcers? Right away, he did find bacteria in the stomach. So, in 1983, he wrote up his findings for the Gastroenterological Society of Australia. But the reviewers rejected it. As far as they were concerned, Dr. Marshall needed something more dramatic than samples of bacteria found on bits of stomach tissue. What he did next is the stuff of legends in the medical research world. He grew a culture of the bacterium Heliobacter pylori, which he had harvested from ulcer patients. He mixed it into a broth, and he drank it. He figured that ingesting this bacteria, which grew very slowly in lab conditions, might give him an ulcer in 2 to 3 years. He was half right. He did get the ulcer, but it didn't take 2 to 3 years. It took 2 to 3 weeks. So he drinks the bacteria. On day 3, his mother notices he has terrible breath. That's a side effect of having bacteria in your digestive system. On day 5, he gets indigestion, and he starts vomiting. And then on day 14, an endoscope, that's a little camera they can stick down your throat to see inside your stomach, it shows massive inflammation and the beginnings of an ulcer. So then Marshall starts taking antibiotics, and within a week, he's on his way back to full health. Now this was reckless and it was irresponsible, but it got him noticed. Not in medical journals, but in the Sunday Star, which it's this paper in Australia that's so bad that Dr. Marshall himself describes it as a tabloid that often features stories about alien babies being adopted by Nancy Reagan. So yeah, it's basically the National Enquirer of Australia. And the headline read,
Guinea Pig Doctor Discovers New Cure for Ulcers and the Cause.
And that is why I wanted to tell his story in this episode, because he dug into both parts of the disease, not just how to cure it, but also how to get it in the first place. It's just like the Sunday Star said, he found the cure and he found the cause. You see, until Barry Marshall came along, anyone doing research on this idea was treating people who already had ulcers. And that is a big part of why they fell short on being able to prove that bacteria caused ulcers. Now, what Marshall did to himself, you can't really do that with human test subjects. If you want a new treatment for cancer, you can't give healthy people cancer. You don't deliberately infect people with HIV, and we don't create new diabetics. And the reasons are obvious. It would be immoral and it would be dangerous. But because we don't do that, we're deprived of examining a crucial step in the pathology of these illnesses. And that is one reason why researchers use animals. To really understand a disease, you have to know how it develops right from day one. And you can't really build experiments to do that with people. Well, unless you're Barry Marshall and your guinea pig is yourself. Honestly, I'm a little bit conflicted about Barry Marshall. On the one hand, he seems like the kind of person we want our scientists to be. He's bold, he's adventurous, he's brave. He's basically the Crocodile Dundee of the medical world. But on the other hand, he could have killed himself. And that is not a great way to do science, and it's not something we should expect from scientists. So I'm not sharing Marshall's story because I want us all to be like him. In this episode about animal testing, I'm talking about Marshall's story for a different reason. There's this layer that I think illustrates something critical to what SciMar is doing right now as they research type 2 diabetes. So, normally, researchers use rodents for diabetes research because a lot of their systems work like those of humans do, and those rats or those mice can come from a breeding facility, like the one in Bar Harbor, Maine from our first story, and be genetically modified so that they already have diabetes. But Dr. Wayne Lott, the lead researcher at SciMar, has pushed back against that approach. He wants to think more like Barry Marshall. He wants to observe how the disease develops and then try to treat it.
The use of mutant animals, it has to be thought through very, very clearly. Disease models based on mutations might give some information, but in this situation, you have to look at what in fact is a reasonable model of the human diabetic pandemic that's going on around the world.
Dr. Lott wants his lab animals to develop diabetes the same way real people do.
This is not a genetic mutation that we're seeing. It's not a genetic problem. It's not a mutation problem. It is a lifestyle problem, and sugar is the main culprit. There's ample evidence to show that when a country becomes wealthy enough to use a lot more refined sugar, the incidence of obesity and type 2 diabetes just goes screaming up from the moment it was introduced.
So what he does is feed healthy rats a first world diet. Then, once the rats start exhibiting the symptoms of type 2 diabetes, he sets out to reverse it. Dr. Lott has always tried to use as few animals as possible, transitioning to human trials as soon as it's practical to do so, but what he's found is that while human trials are much more valuable in many ways, they're also way more complicated.
With the rats, they're all bred to be genetically very similar. They're all in the same housing situation. Their meals are controlled. So you're dealing with a purebred controlled situation. When you move into the human situation, you're dealing with an uncontrolled mongrel. It's really difficult to control what you need to in human studies. So the animal studies are essential to get us to the point where we can move to the human.
So that's where SciMar is now, conducting clinical trials with diverse, messy, mongrel humans, trying to measure the impact of the hormone hepatolin on a wide variety of people with different lifestyles, different genetics, and different stages of disease with type 2 diabetes. It's an exciting process, one that started with animal trials and now continues with humans. So that's it. I'm Dan Riskin. Thanks for joining me on this and every episode of Inside the Breakthrough, How Science Comes to Life. One last thing. I promised you I was going to explain the term guinea pig, so here it goes. The first use of guinea pig as human subject of an experiment, according to the Oxford English Dictionary, was in 1913. Now, if you think back to 1913, actual guinea pigs were at the height of their popularity as research subjects. They played a role in medical breakthroughs ranging from the discovery of vitamin C to a vaccine for tuberculosis, the development of pap smears. In fact, 23 Nobel Prizes for medicine have been handed out to researchers that used actual guinea pigs for their research. And guinea pigs are still used in some research because their immune systems and their hearing are really similar to those of humans, but rats and mice are smaller and they're easier to breed, so that's what most studies use today. When you hear the term guinea pig now, it's usually not referring to guinea pigs. It's slang for a person who participates as a subject in an experiment, or, more often, for the first person to try something that's risky, like biting into a spicy chicken wing, jumping off a bridge into deep water, or walking into a restaurant on Main Street in Bar Harbor, Maine, and ordering the chicken.
Listen to more of Inside the Breakthrough with Dan Riskin, now streaming on Apple Podcasts, Spotify, and Google Podcasts.